Hello, welcome to you all. In the previous video, we discussed about block diagram reduction using Matlab. In this video, we'll first revisit what we did a bit, and then we'll talk about how we are going to do the same in Simulink environment. So, as we discussed, transfer function is the relation between input and output, and it represents the given system. So as you see, the system is g of s in this case, and the output by input relation in Laplace domain, which we call transfer function, is representing that. Now what we did earlier is, if I had to represent the given transfer function in Matlab, we had to have the transfer function has to be in either algebraic form or it has to be in pole zero form. So using these two methods, we did the simulations, or we did the modeling in Matlab. Now we'll do a similar approach in Simulink. But remember, for Simulink representation, we have built-in blocks, which we'll discuss when we go to Simulink. So to have that default blocks, the default blocks that we are going to use is for algebraic form. So when we take the first example that we took earlier, g1 of s equals to 10 divided by s square minus 3s plus 2. If we get the coefficients, it is numerator coefficient is 10, denominator coefficient is 1, minus 3 and 2, that we discussed earlier. Numerator coefficient is 10, denominator coefficient is 1, minus 3 and 2. Now we are going to see the representation of the same in Simulink. Let us open Simulink. Okay. When I open the Matlab environment, let me check again whether my Matlab is currently working. Yes, it is working. So if I want to open Simulink, I have two ways. Either I can type Simulink in this command window, or click the Simulink button. Any one of the two will take you to the Simulink. Sometime it may take more time to get to this window because of the loading issue. If you are doing it for the first time, it may take time. So please wait for some time till it loads this page. Once it loads, please click on blank model because we are trying something new on our own. So in the blank model, we are going to open the library. So in the library, as you all know, that I have source for inputs, sink for output, and the relation between input and output is defined by these blocks. And commonly used or frequently used blocks contains few of the blocks from here which are used commonly. Apart from this, if you are working for specific problem based on application area, you may find more here. Right now we have installed a limited package, but if you install the many packages, you will see a bigger list here. So for as far as our requirement is concerned, we need to go to continuous, because we are looking at continuous signal, which is a Laplace domain. So we'll take this block, which is transfer function block, right click and say add to block. That's it. So when I take this block, double click, I get coefficient for numerator and coefficients for denominator. As the G1 wanted numerator to be 10, denominator as 1, minus 3 and 2. So if you forget, please go back to previous content of this video and check whether it is same. So by this I can represent what I call it as G1. Okay. Similarly, I can represent G2. So I can copy paste. Okay, this is the simplest thing. Control C, Control V, or I can just click here, press Control and drag it. So as you use Paint, all options are possible in this. So when I want to use the second block, which I call G2, I'll see what is G2 is. Okay, G2 has numerator coefficients as 1, 1, denominator coefficient as 1, -5 and 6. I'll also note down the coefficients for H, which is 1 for numerator, denominator is 1, 0 because s to the power 1 is 0, and -6. Okay, I'm going to use these two. Okay, I'm going to double click and I will say this as 1 space 1 in the denominator, -5 and 6. Okay, so with this I represent G2. Similarly, if I want H, I'll just take a copy of this. As we just took the values, please note down those values again if you want to check. So it is 1, 0, -6. If it is wrong, you can always correct it. I hope it is correct. Okay, this is how simple it is. Now, the next thing that we are going to do is trying to play the reduction. But remember, here we don't have to reduce the blocks, as we can connect them in any architecture we want. For example, here it is given them to be connected in series. Either I can represent the whole block, which if I know G1 and G2, or I can represent them in this fashion and connect them. For example, I can connect these two blocks. Now this is in series. Now if I want output, for output I'll go to scope and I'll connect the scope, and for input, let me say I take step input, or I can take if you are not aware about different types of input, go to source and see different types of inputs. Okay, now we'll see the output. For output, you just have to click here. Okay, it runs for 10 seconds and we'll see the output. It can be anything, I am not bothered. Say this is the output after 10 seconds. If I want to see how it looks after 100 seconds, I can rerun it by checking the different time interval and run it. Yeah, this shows that system is unstable. That we'll see later. But remember that whatever the reduction that we do, the reduction was necessary there because we had to simplify it for calculation. But here, as far as Simulink is concerned, that is not the case. So remember that series is something like this. Similarly, if I have parallel, okay, this is also doable without the need for reduction in Simulink. So let me keep this as it is. This I'll delete this. Then I'll add the sum block or add block. So if I have sum or add block, I'll get this. Okay. Okay. Now with this, so if you look at the input, they are both connected to single input. So if I run this, so I get the some output. Let us not bother about the output here much. So it is parallel connection. I can make plus minus by changing the properties here. If I say L minus plus minus, then it will become plus minus. So I can do any modification. So I don't have to actually do reduction. So now we'll see the same for a feedback system. Everything remains same. Here for feedback system, I'm going to delete the links. So G1, G2 are in series for feedback system. H is in parallel. Okay, this will not take because it is for forward path gain. So the reason behind it is not connecting is it has to be connected like this. This is input and this is output. If I want to rotate this, I can rotate saying Control R. So, or something else. Now this is 180 degree shifted, so it looks as per our requirement. If you look at this, this is our requirement. So as per this, it gets connected. Now if I run it, it will have some output. Let us not bother about output. This is how it looks after 100 seconds. So with this understanding, we are able to do all the block diagram simulations in Simulink. Either the reduction is necessary or no, that's a different story, but yes, we can do this in Simulink. Hope you understood. If you have any questions, please put it in comment section. Thank you.